Start us out with number 11 again. Not again, but starting with the number 11. As soon as my camera shapes up, wakes up, let's see what we got. Hey, there we go. Okay, 11. Draw a conclusion for what values of A does the graph have a hole? Well, so the deal is I'd look at the factors of the denominator. That's going to be x plus 1 and x plus 3. So if A happened to be 1, or if A happened to be 3, you would get a hole because these two things would be exactly the same. Then it says, then for each value of A, state the domain and range using interval notation. Okay, well, the domain's not going to change at all, right? So the domain's going to always be negative infinity up to the 2 breaks, which is going to happen at negative 3, and then from negative 3 to negative 1, and then from negative 1 to infinity. Because this right here, where does this equal 0? At x equals negative 1 and x equals negative 3. So now the deal is, if I have A as 1, okay, that's going to give us x plus 1 over x plus 1 and x plus 3. So those will simplify, giving us 1 over x plus 3. And now we're going to let x get really, really close to that negative 1 value that gave us the problem. So that would give us 1 over 2. So our hole would be at negative 1 and 1/2. So that tells us the range then for that one would go from negative infinity and the end behavior is 0, so negative infinity up to 0, union 0 to 1/2, unioned with 1/2 to infinity. Now the domain doesn't stay. The domain stays the same for the other one. We should have to do the same idea here, except for letting x get, or let A be 3. So that'd give us x plus 3 over x plus 1 times x plus 3. Now we're going to let x get really close to negative 3. These will go away. That's going to give us 1 over negative half, so negative 1/2. So then the range would change from negative infinity up to negative 1/2, union negative 1/2 to 0, union 0 to infinity, because again 0 is that end behavior. The end behavior doesn't dictate what the range is. The range just will follow it on a simplistic, on a very simple rational, which these ones are. So how do you identify the asymptotes of a rational? For the vertical asymptotes, we take the denominator, set equal to 0 and solve. For the horizontal asymptote, take what matters most on top, put over what matters most on the bottom, and you see what you get out. If that comes out to be a number, then there's your horizontal asymptote, y equals that number. If it comes out to be 1 over x, or a number over x, any number over x, that's going to lead you to 0, because any number over an infinitely large number is going to 0. If it comes out to be an x, or x squared, or anything like that, that's going to be slant, and you have to do long division to figure it out. Okay? So number 13, calculator allowed. You have to subscribe to Cablevision. The cable company charges a one-time installation fee of $30 a month and a monthly fee of $50. Right, a model gives the average cost. So average cost means we're going to take the cost per month, right? We don't know how many months we're doing. We'll call it M or X. They do a $30 fixed fee plus $50 a month, and we want that average cost to be $56. Okay, so there's the expression. That's the equation that we're going to solve. The question is, when does that equal 56? So, a couple things we can do here. I Identify any asymptotes. There is an asymptote at m equals 0. It's a vertical asymptote. There is a horizontal asymptote at 50 m over m, which is just 50, because the cheapest that it'll ever be is $50, because it's going to cost you $50 per month. You can get that monthly, that one-time installation fee down to really hardly anything if you let the months get extremely large. And then it's going to look something, if I'm not mistaken, it looks something like this. And then 56 is like right up here, and the question is, when does that happen? Do they actually, after how many months they want you to find it? You got a couple options here. You could actually, in all honesty, set them equal to each other, just multiply by m, giving you 30 plus 50m equals 56m. Subtract the 50. I mean, don't regard simple math as not smart. I mean, 5 months you're gonna have, that'll be the average cost. It's $56. Okay, done. 14 says use the graph at the right to identify each of the following things. So, sorry. There we go. So our domain, well, it definitely looks like there's a vertical asymptote at 1. So negative infinity to 1. Looks like there's a hole at 2. 1 to 2. Union then with 2 to infinity. The range. And it looks like there's an end behavior horizontal asymptote at 2. And it follows it. Then where that hole is at 8. Then 8 to infinity. Increasing, when is it going up? Never. Decreasing, always, except for where there's breaks. So that's going to follow your domain. Negative infinity to 1, union 1 to 2, union 2 to infinity. Concave up, that's going to be from 1 to infinity, but it also has that break. So it's got to be from 1 to 2, union 2 to infinity. Concave down would be negative infinity to 1. Vertical asymptote, we already said, was at x equals 1. Horizontal asymptote, we already said, was y equals 2. And there is a hole at 2, 8. And there is an x-intercept at negative 2. And it looks like there is a y-intercept at 4. Negative 4. Average rate of change from negative 2 to 0. So on the bottom, from negative 2 to 0, you can go like this. Negative 2 minus 0, that's fine. At negative 2, find the value, which is 0. And at 0, find its value, which is negative 4. So that's going to give 4 over negative 2, which is a negative 2. There's your average rate of change. Done. All right, let's see if we can rock these out. X squared minus 9, x squared minus 9, they are common denominators, so you can add them. 6x plus a negative 3x is 3x. 6 plus 3 is 9. That gives me, I just always like to factor these out for funsy onesies. Excluded values, I'll exclude them right now. X cannot be negative 3 or 3. Factor out a 3 here. And say goodbye to the x plus 3. 3 over x minus 3 is your solution. Okay, done. Number 16. Common denominator, not a common denominator already. This one is x plus 1 and x minus 1. This one needs the x plus 1. So top and bottom. So on my common denominator, I have x plus 1, x minus 1. I have 4 minus everything I'm going to get out here, which is an x squared, plus 2x, plus 1x, which is a plus 3x, plus 2. So that's really going to give me a negative x squared minus 3x plus 2 all over x plus 1, x minus 1, Factor out the negative just in case this thing can factor out. X squared plus 3x minus 2. Are there any factors of negative 2 that'll add up to 3? The answer is nope. So state your excluded values and you'd be done. Negative 1 and 1. So there it is. Done. Okay, multiplication and division, you don't need common denominators. So I tell you to factor everything. So factor this guy up here first if you need to. They are both prime numbers again. So if they're both prime, guessing check is not that too difficult. Factors of negative 5 got to be 1 and negative 5 or negative 1 and 5. But I want it to be a negative 9x. So if I put a negative 5 right here and a plus 1 right there, 2 times negative 5 is negative 10. Plus 1 is negative 9. Or box it up. Or use factoring by grouping. Factor out of 3 here. That's going to give us x minus 5 times 4 over, again, prime numbers, so it's really not too hard to guess and check. Factors of negative 3, either 1 and negative 3 or 3, negative 1, depending on where they go. So 2 times negative 3 will give us negative 6 plus 1 gives us the negative 5. There it is. Your excluded values, x cannot be 5. Sorry. There we go. X cannot be 5, x cannot be negative 1/2, and x cannot be 3. Say goodbye. That's it. So up top you have 4 over 3 times x minus 3, and I'd leave it just like that. Okay, you're done. 18. So with division, I'd still tell you to factor everything first. Leave it as divide for just a second. Okay, that's going to show us that our excluded values is x cannot be 4. X cannot be 4. Now remember, this divide here also makes that x cannot be 0. Can't look at that one. So now we have to change the divide to a times. Take both sides, or not both sides, but take the second one and flip it. So we get x minus 4 simplify out, and that's it. So I get 3 times x plus 2 over x. I'd call that a day. 19. Here we come. So we're adding again, so we need common denominators. This is x plus 5, x minus 5. This already has an x plus 5, so x plus 5's got to be in your common denominator. X minus 5's got to be in that common denominator, which means this one is only missing x minus 5. So that's going to be 4x minus 20, because it's distributed in the 4, plus these two here, and these two are exactly the same, so it's just 2x. So that should give you 6x minus 20 over x plus 5 and x minus 5. Excluded values, x can't be negative 5 or 5. You can factor out a 2, which will give you 3x minus 10 over x plus 5 and x minus 5, but that doesn't do you any good because they're not exactly the same. Done. Okay, again, we have common denominators. Be careful to subtract. So 3x minus x, which is 2x. 2 minus 5, so negative 3 all over x minus 2. Your excluded values, x can't be 2. Can't factor this. You're done. Well, that page was nice and simple. Try to get another one of those rolling here, huh? Here we go. So, factor this big bad boy up here. They're both prime. So you can hippo butt. 2x squared is what times what? Negative 3 is 1 and negative 3, and you want this to be the negative, this to be the 1, because 2 times negative 3 is negative 6. Plus 1 is negative 5, which is what we want, over. This is a difference of, not squares yet, until you factor out the 3. Once you factor out the 3, now you have a difference of squares. So that's going to be x plus 3, x minus 3, times, here we have x plus 3 over 2x plus 1. Okay, state your excluded values. we would say x cannot be negative 1/2. X cannot be negative 3. That's it. Say goodbye. Leaving us with 1/3 done. 24. Factor everything. 4 times x minus 3 over x minus 4. Keep it as a divide just for a second. X plus 4. X minus 4. State your excluded values. X cannot be 4, negative 4. Don't, because of this divide here, x cannot also be 2 because you can't divide by 0. Okay, you don't need common denominators when you're multiplying and dividing. So change the divide to a times. Flip the second. Say goodbye here. That's all we got. 4 times x minus 3 times x plus 4. You don't need to multiply it out. Just leave it done. You're done. Okay, 23. Rocking and rolling. Hippo butt, hippo butt. X squared is what times what? Factors of negative 6 to add to 1. Positive 3, negative 2. Over x squared, which is really just x times x. Times. Factor out an x here. X minus 4 over hippo butt, x squared is what times what? Factors of negative 12, add to negative 1, negative 4, positive 3. Excluded values, x cannot be 0, or 4, or negative 3. Now, say goodbye. Leaving us with on top, x minus 2, on bottom an x. Done. Okay, we're trying to add these together. They're not like, they don't have an LCD, so we need to get an LCD. So x minus 4's got to be there. X plus 4's got to be there. So multiply this one by x plus 4, top and bottom. It's going to give you 3x plus 12 plus, multiply this one by x minus 4. It's going to give you x squared minus 4x. So that gives us x squared minus x plus 12 all over x minus 4, x plus 4. See if this will factor. Are there any factors of 12 that you had to know to negative 1? If it was negative 12, you'd be okay, but positive 12, no siree, Bob. So just state your excluded values and you're done. X cannot be 4 or negative 4. Done. 25. Well, I tell you to factor this guy first to figure out what we got. X plus 4 and x minus 4. Factor out the 2 here. X minus 4, so in my LCD, x minus 4's got to be there, which represents that one. X plus 4's got to be there, which represents that one, and the 2. Okay, so what is this one lacking? It's lacking a 2, so I multiply this one by 2. That's 8x. Minus, I'm going to subtract out everything I get over here. This one's lacking the x plus 4, top and bottom. So that's going to be 1 times x plus 4, which is x plus 4. 8x minus x is 7x minus 4 over 2 times x minus 4 and x plus 4. Therefore, state your excluded values. X can't be 4 or negative 4. Folks, that doesn't factor. And oh my gosh, I ran off the board there. Hello. So, 7x minus 4 doesn't factor. We're done. Okay, here we go, 26. Factor everything. Hippo butt, x squared is what? Times what? Factors of 16 to add to 10. That's going to be 2 and 8. Hippo butt, x squared is what? Times what? Factors of negative 16 to add to negative 6. That's going to be negative 8, positive 2. Leave the divide alone for a moment. We have x plus 8. We have x plus 8 and x minus 8. State your excluded values. X cannot be 8. X cannot be negative 2. X cannot be negative 8. X cannot be 8, and x cannot be 8. Okay, we're good. We got our negative 8, and we got all those. Okay, good. Now take the divide, change it to a multiply, take the second one and flip it. Some people say dividing by fractions is as easy as pie. Flip the second and multiply. Now you say goodbye. Leave us with just x plus 8. Done. Okay. Oh, baby. Man, we're getting there. This last page. Oh, yeah. Last page. Last 5 problems. Let's get her done, son. Get her done. So, to solve, this is when you have an equal sign. When you have an equal sign, you want to eliminate your denominator. So, first I tell you to factor the denominator out because I can easily see that that's going to that. Now I want to multiply by the things that I'm dividing by, which in this case is a 2. Dang it. Sorry, this is getting kind of messy because this staple thing here. Sugar booger here. Let's do this. I'm just going to rip it off. I apologize for that. Okay, that's going to make it a little bit easier for me to write up there in that corner. Good. Okay, so I want to multiply by 2. And I want to multiply by x plus 2. Now remember, x plus 2 is already being multiplied by there. I only need it twice if it happens twice in the same denominator. Once, 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 once. Once here, once there. Once here, once there. I'm going to distribute in here, here, and here. Gives me 2 times. Oh, and this is like all over 1. So I get 2 times x plus 2 times 3 all over x plus 2 plus 2 times x plus 2 times 3 all over 2 times x plus 2 equals 2 over x plus 2 times x over 2 times x plus 2. Okay, say goodbye. Eliminate your denominator. The whole reason you did what you just did. So that gives us 6 plus 3 equals x. Or in other words, x equals 9. Make sure you check your excluded values. X cannot be negative 2. Alright, 9 works. You're good. Okay, look at number 28. Alright, so x minus 8 has to be in that LCD. This x minus 8 is already there. I don't need 2 of them. I only need 2 if it appears twice in one denominator. So it's like over 1. So I multiply here and here. That gives me x minus 8 times x over x minus 8 equals x minus 8 times 24 minus 2x over x minus 8. Say goodbye. Giving us x equals 24 minus 2x. I would add the 2x over. Give me 3x equals 24. Divide by 3. I get x equals 8. Make sure it's not one of your excluded values. X cannot be 8. Oh, baby. This guy has no soul. Okay, I got to hurry. That was the bell. People are going to try to start coming in. Okay, I got to hurry here. In fact, let me open my door. Well, they can sit outside for just a second. So here we go. Hippo, butt, x plus 2, x minus 2, hippo, butt, x plus 2, x minus 2. And multiply by everything you're dividing by, which is x plus 2 and x minus 2. And it only happens once in all. So there you go. You're going to bring it here, here, and here. When you bring it here, these guys go away, leaving you with just 8x. Minus, when you bring it here, the x plus 2's are going to go away, which means you're going to get 4 times x, which is 4x, and you're going to minus that. That's a minus 4x. You're going to get 4 times negative 2, which is negative 8, and you're going to minus that, which is a plus 8. So be very careful right there with your signs. Okay, you could attach the negative to the 4 if you want. Take negative 4 times x, negative 4x, negative 4 times negative 2 plus 8. Here, when you bring it here, they're both going to go away, leaving you with just 8. That's going to give us 4x, subtract the 8 over. That's going to give us 0, so x equals 0. What's your restricted values? X cannot be negative 2, X cannot be 2. So you're good with 0. Done. I hear people at the door. Give me just a second. Okay, here we go. Multiply by your LCD. X plus 1 has got to be there. 2 has got to be there. X has got to be there. You're going to bring it here, here, and there. So think about it. When you bring it here, the x plus 1s are going to go away. You're going to get 2x times 3x, which is 6x squared. When you come here, the 2 is going to go away and the x is going to go away, leaving you with just x plus 1 times 6, which is 6x plus 6. Equals, when you bring it here, the x's are going to go simplify out, giving you 7 times 2, which is 14, times x, which is 14x, and 14 times 1, which is 14. This x squared isn't going anywhere. Get everything on the same side. Subtract 14x and the 14 over. Okay, get this thing equal to 0, and you're going to look to factor this baby. So it's going to be negative 8x minus 6x squared. If I were you, I'd probably factor out a 2 first. Try to get this thing down as much as I could. 3x squared minus 4x minus 4 equals 0. Then let's box this thing up. So I have 3x squared. I have negative 4. That's going to be a negative 12x squared. Factors of negative 12x squared. That to negative 4 happens to be 2 and negative 6. So 2x, negative 6x. GCF left and up. GCF left, this is x. GCF here, this is going to be a negative 2. Okay, so there's one of your factors, x minus 2. Okay, GCF up, this is 3x. GCF up here, this is 2, and that's a plus. So it's 3x plus 2, so you get x equals 2. X equals negative 2/3. Check your restricted values. X cannot be, looks like it cannot be negative 1. X cannot be 0. You're good. How do you add and subtract and identify excluded values? Add and subtract to get common denominators. Add or subtract just the tops. Exclude the values from the very beginning for everything on the bottom. Make it 0. Folks, we're done. I got to let people in. We'll see you later, taters. Bye. I'm coming. I'm coming. No, I feel like I ain't. No, but I think it's flu. Okay. Sorry, I was working on your review videos. It's okay. It's okay. It's all good. Hey, we'll see you. Have a good one, Sam.
I thought you weren't here.
No, I'm here, baby. I'm here.
Daniel Frito. I was being sick.
Sucks. Still am sick.
What did you have? The coronavirus.